So more examples about the mole concept. Here I do have, this is similar to number 54 in your homework, you guys. So how many hydrogen atoms are there in that much water molecules? So now I need them. I'm given the molecules. I am here, and I need the atoms. Okay. So how many hydrogen atoms are there in that much water molecules? So actually, I am here. I don't need any of the mole or the mass or anything like this. I'm given the molecules and I want to relate this into atoms. You know that water molecule is made up of two hydrogen atoms. So you can easily get the number of atoms in there. So you start with the given, and your given is the 6.023 times 10 to the 23 water molecules. So this is going to be your given 6.02, 6.02, not 23, times 10 to the 23 water molecules, right? I want the hydrogen atoms. So I know that there is not one, there is for every one water molecule, so that the water molecules will cancel out. So one water molecule that is made up of two hydrogen atoms. So you can build the relationship as you want, as long as you understand what you need in there, and you understand what does the molecule contain. So always the molecule is related to its individual atoms. It's the sum of its individual atoms. So one mole of or one molecule of water has two hydrogen atoms, and also I can build the same relationship with one molecule of water has one oxygen atom. So it really depends on what they are asking me. Okay. Here you go. Okay, so I am gonna take out the water molecule in here, and I'm gonna be left with the hydrogen atoms. So you can go ahead and calculate your answer with this. The last equation in this chapter is the mass percentage of an atom in a molecule, and this is equivalent to this is the percent of the atom. It's equivalent to the mass of the atom divided by the mass of the molecule times 100. And the question is going to be like this. What is the mass percent of carbon and carbon dioxide? See, carbon dioxide is made up of one carbon and two oxygens, right? So I want the mass percent of carbon in there. So to get the mass percent, what you need to do is do the formula, which is the mass of the atom divided by the mass of the molecule. So it's the mass of the carbon divided by the mass of carbon dioxide times 100. Okay? The mass of carbon dioxide is the molecular weight of carbon dioxide that you can easily go ahead and calculate. So the mass of the carbon dioxide, that is equal to this guy here. So it's going to be 44.01 gram of CO2. Okay. This is the mass of the carbon dioxide. And the mass of carbon is 12.01 grams of carbon. So you're going to take 12.01 grams of carbon. We're going to divide this by 44.01 grams of CO2, and we're going to multiply this by 100. The answer is going to be in percentage. So I have that much carbon. Okay. Now, if I continue and say, okay, how much oxygens do I have? We're going to do the same thing. We're still going to use the mass of the carbon dioxide, but now we're going to use the mass of the oxygen. And the mass of the oxygen here, I have two oxygens. So the mass of the oxygen is 16 times 2, so it's going to be 32. So I have the mass of the oxygen divided by the mass of the carbon dioxide times 100. The mass of the oxygen is the total number of oxygens in the molecular formula, which is 32.00 grams of oxygen divided by 44.01 grams of CO2 times 100 in this case. That is 72.71%. You guys notice that if you go ahead and add these two numbers together, your answer is going to be 100%. So notice that the percent of carbon plus the percent of oxygen in the molecular formula is 27.29% plus 72.71%, and that is equivalent to 100%. So simply, you didn't need to calculate the percent of oxygen. You calculate the percent of one element in there, since the carbon dioxide is just made up of two types of elements. So you just calculate one element and do 100 minus the percentage of that element, and you get the second. Okay? Let's have another example here. So what is the weight percent of sulfur in K2SO4? Okay, so K2SO4 has multiple elements in it. It does have potassium, it does have sulfur, and it does have oxygen in there. The potassium is two potassium elements. It does have one sulfur element and four oxygen elements. So the first thing I would do, I would calculate the molecular weight for K2SO4. Okay. Go to the periodic table and get the mass of the sulfur. So it's 32.07. It's one sulfur, you guys. So you don't have to multiply the answer by anything in there. It's just 32.07 divided by the mass of the whole molecule times 100. So I know that the percentage of sulfur is going to be equal to 18.4 in there. If I ask you, okay, what's the percent of, let's say, oxygen in this structure, then you go by the mass of the oxygen divided by the mass of the K2SO4 times 100. You cannot say, okay, it's 100 minus this one, because the K2SO4 is made up of three elements, and it is not made up three different elements, and it's not made up of two. So pay attention to that. So now the percent of oxygen in there is going to be the mass of the oxygen. It's four of them. So the mass of oxygen is four times, this is going to be 4 times 16. Yeah. So it's 4 times 16. 4 times 16 divided by the mass of the potassium sulfate, which is 174.25 times 100, and you get your answer. Now you can add this one, you can add these two together, you subtract from the 100, and you get the mass of the potassium, or the percentage, not the mass, the percentage of the potassium in your formula. Okay, another example. Which element is approximately 65% sulfuric acid by weight? So I have hydrogen, sulfur, oxygen, and any of these. Hydrogen, so here you go. I know that sulfuric acid is made up of 2 hydrogens, a sulfur, and 4 oxygens. So I would need to calculate the percent weight for these elements. So calculate the percent weight of the hydrogen, the sulfur, and the oxygen, and see which one is the highest. Now it makes sense that this oxygen here, because it is 4, it's supposed to be a high percentage, and 65% seems to be a high percentage. So that is equal to the mass of the oxygen. Please remember to multiply by how much oxygens you have. Don't forget this, okay? Because if you don't, your answer is going to be wrong. Divided by the molecular weight times 100, so the answer is going to be 65. I did do the percentage of both the sulfur and the hydrogen just to make sure in there, but you can also check your answer by adding those up. So take the 65, add it to the 6, add it to the 32.4, and your answer has to be 100%. If it is more than 100%, there's something wrong in your calculation. Okay. The last one over here. What is the number of moles of water in 1 liter of water if 1 gram of water takes 1 ml of space? Okay, so here what I have is the volume. Okay, so I am given the volume in there and the moles. I know that this is 1 liter of water. So from the liter of water, okay, I can get the density, because I know that the density, let's see, so in 1 liter of water, if 1 gram of water. So yeah, so I'm given the gram per mil. This is what I'm given. So the gram per mil is what I know. And the gram per mil is what? This is the mass. This is the volume. If if you divide the mass by the volume, you get the density. So you're given the density actually of the water in there, which is grams per mil, and I need the number of moles. So this is going to be my given, okay? I'm starting with this. I'm starting with 1 gram of water per 1 mil. So let's go ahead and build our equation. So I'm starting with 1 gram of water per 1 mil. I need the number of moles, right? So to get the number of moles in there, let's see. First, what I need to do is change the mils, because I need to get rid of the mils. So I have to get rid of the mils in there. And to get rid of the mils, I need to relate this into liters. This is what I need to do, because it says that the number of water in 1 liter. So I need the answer to be moles per liter. So at the end, I need my answer to be moles per liter. This is going to be my guide. So I'm going to change the mils into liters. So I'm going to take out, so it's going to be moles per liter. I need the liter in the denominator. So I know that 1 liter is 1,000 mils, right? So I'm going to take the mils out. So my answer now is grams per liter. I want to change it into moles per liter. So I know that 1 mole of water is equal to 18 grams of water. Okay, so the grams of water and the grams of water will cancel out, and then I'm going to get an answer of moles per liter. So see how I solved this one here? I did put the given, which is the grams per mils, and then I put the unit that I'm asked to. I'm asked to find the moles per liter. And then I did a series of conversions in order to get that unit. I started with the grams per mil. I changed the mils into liters, but I need the liter to be in the denominator. So this is why it's in the denominator over there. And then I related that into number of moles so that I can cancel the grams and I would be left with just the moles. Every time you want to introduce a mole, you need to introduce the molecular weight, because this is your only way to get the moles as the unit. Okay, so your answer here is going to be 55.6 moles per liter. Guys, the homework, the problem set homework for this chapter, it has a key, and the key is uploaded as well. It's a detailed key, so please go ahead and look at it and do your homework. Do your homework. Even though there is a key, I want you to go ahead and do your detailed homework. The way that I would prefer that you work your homework is test yourself after you listen to the lecture. Go ahead, open the homework, don't look at the key. Open the homework and go ahead and try to answer the questions in the homework. If you find any difficulty, look at the key. If you still have more difficulty, I'm here. Just go ahead and let me know. Okay?